Here is our third example for the section 8.7 surface area. And this one is the surface area of a cone. Find the total surface area. Well, just like a cylinder, of course, the cone has a base that is a circle. But since it's a cone, there's only one circle, just one base. But the other part is the lateral area of the cone. And again, we're given some dimensions here. We're told that the radius of our base right here is 5 centimeters. And we're told that our slant height, right here, the slant height, is 10 centimeters. 5 centimeters and 10 centimeters. So that's that part. On the side, though, notice that, I don't know if you can imagine a couple different types of things that I can think of here. Maybe a party hat that you would wear at a child's party looks kind of like a cone. Or maybe the covering on an ice cream cone that you might get during the summer that's got the paper cone to kind of prevent you from getting too messy. But if you took a scissors and cut from the circle part, like right here, up to the vertex or tip of the cone, basically along the slant height, and unfolded it, you would get this fan-like shape right here. And that's what we want to get the area of. Now this dimension right here, from here to here, is that slant height dimension. So that's that 10 centimeters that we were talking about back in the original diagram. But notice what happens on the fan part. We've got all of these basically little triangular regions that we can make right here. And all of those triangles can be put together and then jigsawed back and forth to make a shape that looks kind of like this. And the more and more triangles that we have, the more and more rectangular that shape is going to be. And the side of that rectangle, again, will be that slant height, it's that L, which in this problem was the 10 centimeters. But the length of the base of this rectangle right here is actually half. It's half of this right here. And this right here came from the circumference of this circle over here. So this entire distance all the way from here all the way to here is actually the circumference pi d, or 2 pi r, 2 times, or pi times 2r, you might think of it like that, because 2 radii is the same thing as a diameter. But basically this rectangle, we're dividing that into 2 equal parts. So we've got this half right here, and then we've got this half over here. So the base of that rectangle is half of pi d, or half of pi 2r, which is basically just 1 pi r. So this distance right here, the base of our triangle, is pi times the radius. And then the other one is up here, so that's also pi r. So then you've got 2 pi r's if you want to total those up, which this distance plus this distance would be the entire circumference. All right, so as you can see from the diagram, when unfolding the cone's lateral area, we get triangular pieces that can be cut apart and formed into a rectangle. The rectangle's area will be pi r times L, which is basically base times height of the rectangle. So the lateral area is pi r L. So that is a little formula here that you might need to kind of stock away on your memory bank, because that is different than some of the other formulas. That's something we need to add in here. But hopefully you kind of understood that basic explanation of why it is pi r L. All right, let's actually get to calculating the area of the base and the lateral side. So the area of the base is a circle, so pi r squared. And the radius was 5, so pi times 5 squared. So 25 pi, and so I'll just put that down here, 25 pi, and I guess this one would be square centimeters. And then let's look at the area of the lateral side. So we just talked about the area of the lateral side of a cone is found by pi times radius times the slant height. All right, in this problem, we had pi, and then the radius was 5, and the slant height was 10. Okay, so putting that all together, 5 times 10 is 50, so 50 pi, and therefore the lateral area is 50 pi square centimeters. All right, now it's just a matter of totaling those up. So total surface area is 25 pi, which is the base, plus the 50 pi, which is the lateral area. So that is a total of 75 pi square centimeters, and that is approximately 236 square centimeters. So on each of these problems, the main strategy is total up all of the parts. Total up the bases, total up the lateral sides, and for the most part you have the formulas for those. Well, for sure you have the formulas now, but you knew the formulas before going into this section. The one little formula that we added was this lateral area of a cone. Otherwise, you're just adding up all of the parts to get the total surface area.